All right, so today in 5-2, we are going to verify more trig identities. So here are some guidelines that hopefully you've learned, and we're going to do some problems that deal with each of these guidelines. So one of them, work one side of the equation at a time. So if you have one side of your equation that's really simple, haven't we learned to work the more difficult side first? The goal is to try to get both sides being equal. You're not always, like on this one down here, you're not always going to get sine squared equals sine squared. But I'll bet you on this one you will. And you're not always going to get 1 equals 1. I mean, technically you could make every single one of these be 1 equals 1. When you get the final answer, couldn't you just divide both sides by what it is and you end up with 1 equals 1? So some teachers do make you get down to 1 equals 1, but you have to show appropriate work as you go along. I would prefer that you get to as simple as possible. So like on these two, you're going to work one side only. So you're going to work this side, you're going to work this side. The second step suggests that you look for opportunities to factor an expression. So we talked about how do you factor things with trig. So aside from taking out a greatest common factor, that's where you would substitute in x for your trig, you know, your sine, cosine, or tangent, and then you would factor it like a normal polynomial, quadratic, and then substitute it back in, right? Also, you might have to add your fractions together into one fraction, square a binomial, create a monomial denominator. So one term in the denominator is always better than 2 or 3. The third guideline, look for an opportunity to use the fundamental identities. That's the identities that I gave you on that whole front sheet of 5-1. So we're always trying anything that's squared. Your ears should be perking up for that. And so, oh, I'm trying to get that squared. Because we have a lot of identities where we can swap out things that are squared. Note which functions are in the final expression that you want. So like here, I'm looking for sines, looking for secants. I could even, if I had, what is the inverse of secant? Okay, so I might, if I end up with cosine over here, or like 1 over cosine over here, I could change the secant into 1 over cosine. So it's possible. I'd rather you didn't. I'd rather you keep it secant rather than cosine. 4, if the preceding guidelines do not help, try converting all terms to sines and cosines. Isn't that something that I suggested to you yesterday? Go simpler. And then number 5, just try something, anything. If you don't know where to start, I suggested start where it seems more complicated and try to simplify it. Even making an attempt that leads to a dead end gives you some insight as to, okay, that didn't work, so let's back up and try something else. So let's look at these examples and see how we do. All right, you're going to help me along. What might I do first? Okay, so we have a secant squared and a minus 1. What can I replace that with? Okay, so I'm going to replace this whole thing with, well, let's look at the identity though. What is the actual identity? Tangent squared, what, of x? Is it plus 1 or minus 1? Plus 1 equals what? Secant squared of x. So am I replacing secant squared of theta minus 1? Or am I replacing just the secant squared of theta? Okay, so I could subtract 1 from here, and I would get tangent squared of x equals secant squared of x minus 1. And now does it look like that? Okay, so I can, as long as I do that, we're good. So I'm going to substitute that whole thing for tangent squared of x over secant squared of x equals sine squared of theta. Say that again? Oh, sorry. Well, I guess I have theta on one side and x on the other.
Can we have a fish?
If you want to use the fish, use the fish. I don't care. All right, so now what can I do? I'm trying to get to a sine, right? Okay.
But it's sine squared over cosine.
Okay, so we're going to replace tangent as sine squared theta over cosine squared theta over What am I going to replace secant with? Okay, so secant becomes 1 over cosine squared theta. Don't forget your equals. Do not drop that off. So it equals sine squared of theta. Because remember, this is like a proof. If you drop off the right side, you're going to lose some points.
You can multiply the
Right, so we're going to take the numerator, sine squared of theta, over cosine squared of theta, and multiply it by the reciprocal. Cosine squared of theta over 1 equals sine squared theta. Too many thetas. So now my cosines cross out, and I'm left with sine squared theta equals sine squared theta. That is my answer. No, that's my answer. I prefer that you leave that as your answer.
Are you gonna like those when to continue forward wrong and like simplify it
You're
more?
supposed to know. Like, for instance, if you can get one side to look exactly like the right side, you know, or the left side, or the right side looks like the left side, then you're done.
Are we always gonna stop there though?
Yeah.
Okay.
Yeah. Okay, so then look at number 2. Which side looks more complicated? The left side. What do you think we might do? They are conjugates of each other, right? So shouldn't I make them into one fraction? Remember, one of your tools is to make 2 fractions into one. So the LCD is equal to 1 minus sine of theta. No, times 1 plus sine of theta, right? Now, if we multiply that out, it will become, it's the difference of 2 squares factor pattern, so it really is 1 minus sine squared theta, right? That's what I would prefer you write once we do this. What is this fraction missing? The 1 plus. So we're going to multiply top and bottom here by 1 plus sine of theta. 1 plus sine of theta. And then this one's missing 1 minus sine of theta times 1 minus sine of theta. So we end up with 1 plus sine of theta plus 1 minus sine of theta all over, and I'm going to write this LCD, 1 minus sine squared theta equals 2 secant squared theta. I ran out of ink. No. Yeah, because of the addition and subtraction. You want to know, can't you cross out the sine squareds? Is that what you're asking? You can't cancel these out, right? But in the numerator you can.
That's what I'm talking about.
Yep, you can do that here and here. Don't they cancel each other out? So this is like the one, was it the one that Paris was doing on the board today? It's very similar to that one, right? And so you got 1 plus 1 is 2 over, can I replace this with anything? Yes, what? Cosine squared theta is equal to 2 secant squared theta. Now what shall I do? Okay, so I'm going to say that it's 1 over secant squared of theta equals 2 secant squared of theta, so you can see why I'm doing what I'm doing, right? So then I'm going to take this and multiply it by its reciprocal. Don't I end up with what I'm looking for? 2 secant squared of theta is equal to 2 secant squared of theta. And to answer your question, Danny, that to me is acceptable. If you want to divide the 2's out, that's fine. It's not necessary. Not so stressed today, are you? Michael, I told you not allowed to boast about that anymore. Abby, you okay with it? Did I go too fast? Doing your homework would help too.
I did it yesterday.
But I wanted you to master it yesterday. Yeah, so this multiplied by the reciprocal of this would be secant squared over 1, right? So that's how I ended up with that. Does that make sense? Okay. All right, so let's flip it. Okay. Now we have a cosine squared x minus 1. And we have this. You've got to be careful with this one when you're switching it. So let's look at the original sine squared of x plus cosine squared of x equals 1. That's the original, right? I want to make this look like this right here. So I'm going to keep the cosine here, right? I'm going to subtract the 1. Yeah, so doesn't the sign, aren't we going to end up replacing it with a negative sign? So I'm going to subtract the 1 from both sides. And I'm going to subtract the sine of squared x to both sides. So I'm really left with cosine squared x minus 1 equals a negative sine squared x. So be careful when you're subbing, because a lot of you would have subbed that with just a sine squared x. What am I going to replace this with? Okay, so this gets replaced with secant, because that's a direct conversion, right? Secant squared x. And then this gets replaced with a negative sine squared x equals negative tangent squared x. No, because we want the negative, because the left side's negative, right? So one. Oh, you could, but I just wouldn't. I avoid trying to do things to both sides, like you're trying to solve an equation at all cases, at all costs, unless I have to. So this is the more complicated, isn't it? Secant squared. What can you convert secant squared into? Okay, so we've got 1 over cosine squared x times negative sine squared x. I'm going to put that over 1 on purpose. Equals. Yep. So I would actually do one more step and combine them into one fraction. Because remember, you're trying to prove it to me. So more work is better than less work. And now can't I say that this is negative tangent squared x? How'd that one go? The key to that one was the negative sine squared x. All right, so look at 4. What might we do first? We have a fraction over here, right? That fraction does not have anything squared, but we could deal with it by multiplying by conjugate, right? So that's an option. We can multiply top and bottom by conjugate. Think of what would be easier, multiplying this by the conjugate or trying to get this to look like 1 minus sine of x. Sure. Yep. I know that you're looking at this and going, oh, I don't want to deal with this. But how easy is it to take something and turn it into a fraction? I'd rather take a fraction and turn it into this. Or I can at least, at the very least, maybe get rid of secant and, because what is secant? 1 over cosine. And tangent is sine over cosine. So I don't know that that would do us any good because we can't cross cancel anything, right? So I probably would leave this just as is. So let's work with the conjugate. You can't because it's not a squared. It's not 1 minus sine squared x. So do be careful with that. Dakota? Well, the secant's going to be 1 over cosine, and the tangent's going to be sine over cosine, so you can't cross cancel anything. They end up being sine over cosine squared. See what I'm saying? All right, so let's multiply by the conjugate. 1 plus sine of x, 1 plus sine of x. So the left side stays the same. I'm trying to decide whether I'm going to distribute the cosine or not. I think I won't. I think I'm going to leave it for right now. We'll decide in a minute if we want to. What does this become? Very good. Now what can I replace this with? So look over here at this one. Yep, well, yeah, because if I got 1 minus there, then you got your cosine left, right? So we are going to rewrite. So was it a good thing that I did not distribute? Wouldn't you agree? And so here's why. One of these can cancel, bless you, with one of those. So what I have is secant of x, tan of x, equals 1 plus sine of x all over cosine of x. You're like, well, how did that help?
How do you just put cosine squared?
Because this is no different than having x and x squared. Don't you subtract exponents with like basis?
Oh, I thought you canceled it completely.
No.
Okay.
This cancels completely, but there's 2 cosines here and there's 1 cosine there.
So that, now just cosine of x.
It's just a plain cosine of x, it's not squared anymore. Danny?
I think the minus 1 on the bottom.
Here? Up here? This one right there? What minus? Oh, right here? Okay. Remember, if I have x over x squared, don't we, isn't the exponent rule that when you divide like bases, you subtract exponents?
Yeah.
So this is really to the first, so I'm canceling this out with one of those and we use subtraction. So that's where that one comes from. Yes?
Forget the
Oh, thank you. That would have been a problem, huh? All right, so are we good to go? All right, so what are your thoughts? How can I make this look like that? Break into 2 fractions, right? So I've got secant of x plus tan of x equals 1 over cosine of x. Is that a good thing? Because isn't that secant? Plus sine of x over cosine of x. Is that tangent? We just have one more step then, right? So secant of x plus tan of x equals secant of x plus tan of x. Verify. The more you do, the better you get. Yes.
Is there like a way on the test? Could you just not give us a head start, or just like tell us what to solve for, like which side of which
I want you to try to figure out what side you should be solving for. And my suggestion is always take the more complicated side and try to convert that to what looks like the simpler side. And so that's why on this one we took the more complicated side, which was the fraction, because you tend to not like fractions.
Well, I guess what I'm saying is like I know how to do it fine. It's just like once I get down to secant of x and tan of x.
Well, notice that so far I haven't changed.
Yeah.
I've only worked one side so far,
Yeah,
right?
I get the need to like subtract tan of x from both sides, and I'll get secant of x equals secant of x. That's not what we're doing.
No, I mean you could, but stop. Once you get the left side equaling the right side, stop. I would avoid adding or subtracting anything to both sides, or multiplying or dividing both sides by anything as much as possible. And you've rarely seen me do that, right? So try to avoid that because we're not trying to solve for x. We're just trying to get the left side looking like the right side. Now, when we get to example 5, this is an example of where you might want to work 2 sides simultaneously. Don't they both look complicated because they're both fractions? Yeah, well, we have a couple of options. I mean, this happens to be a proportion. I mean, we could cross multiply and solve, but that might give us some issues because those aren't exactly conjugates of each other, are they? No. So if we work each side separately, if you were just looking at this side, what would you perhaps do? You might do the conjugate, right? Does the cotangent and the cosecant have anything in common? Is there any identity associated with them?
Zero.
What's the identity associated with cotangent and cosecant?
1 plus cotangent squared u is CX squared.
Okay, so that might be helpful, wouldn't it? So let's work the left. So we're going to multiply top and bottom by cosecant of theta. 1 minus cosecant of theta. And so again, well, we have an option here. We could do this, or we could switch this out, couldn't we? If we switch this out, what would we get? Because I'm trying to think what would be the easiest. What do I switch that out with? This is sine squared? What's the cosecant one again? Say it again. Whoops. Isn't that what you just told me? Okay, so what do I substitute that for? Minus 1. Couldn't I can make that into that, couldn't I? Watch what happens. So if I swap this out, for cosecant minus 1, let's just go ahead and do that, because watch what happens. It'll actually be easier. So we're going to swap this we're going to subtract 1 from both sides. So we've got cosecant squared theta minus 1 over, and I'm going to reverse this and make it cosecant of theta plus 1. There's a reason for my madness. Do you see the reason for my madness? This is the difference of two squares factor pattern, isn't it? So sometimes you want to ponder your options before you move along. We could have done up here the conjugate, but this is actually an easier path, isn't it? So factor this. Won't you have cosecant of theta plus 1 and cosecant of theta minus 1? All over, I'm going to put this in parentheses, cosecant of theta plus 1 equals. And then these cancel out. And I get down to a cosecant of theta minus 1, which is somewhat simple, right? So let's work the other side and we'll see if we can get the other side to a cosecant of theta minus 1. Oops. Anybody have any thoughts as to what I might do to the right side to try to get here? Does sine have any relationship with cosecant? Sine is an inverse, right? So what might your thought be on how I might get there? Because they do have a relationship. Amber says separate them into two fractions. Will that work? Let's see. So separate this into two fractions because that's one of your tools in your toolbox, so to speak, right? Minus sine of theta over sine of theta. What's 1 over sine of theta? Cosecant of theta minus what's sine over sine? 1. Didn't we do it?
Yeah.
So rewrite it again. Done. So this one was a little harder. There's more than one way to approach these. Some ways are easier than other ways. It doesn't mean that if we had gone about the conjugate that we would have done it wrong. Just might have been a little bit more difficult. It would have been longer, maybe. All right. Questions? Pardon? On example 4. What's your question?
On the very last step,
Yep. This one here?
trying to figure out how
Try to be quiet so that I can hear his question.
did you get from the last step to that answer?
Isn't 1 over cosine secant of x? Right? And isn't sine over cosine tangent of x? That's why. It's knowing those inverses and the properties and all that stuff on that one page so that you get used to substituting them in. Okay? Any other questions? Yes. Yes.